And there we go. Now let me share. All right, so let's take a look at what we have on my syllabus. I don't know if I've changed the syllabus or not. Let's see. Today we're doing 4.5 and 9.3. Today is what day? The 23rd. Then on the 28th, you will have a review. So let's write those things down. Get up a new one of these. I don't know if I want that one today or not. And if you have questions, I'll switch it if I have to. I'll put this because this is not going to be pleasant today. Then what do we meet next Monday? Next Wednesday. That then I guess would be 3:30. Of course, you take the test in here. So we have approximately a little less than 168 hours till then. Where was I going to go? I saw something in my email today that may be useful to you in this class, and that is this thing. You tell me if in fact you're interested in this, and I can put this. Oh, I guess you should probably be able to see it too. It's hard to see. I'll tell you this, Herman Nolan works in the tutoring center. And it says he is specifically ready to work with math 0955 students. So he's been focusing apparently on this particular course. You with him? Here we are. This is what I'm looking for. This guy right here. See that email? Herman.Nolan. That guy right there, you want to take, if you're struggling in this class, you want to take that down because he will work with you apparently one-on-one sometimes through WebEx or in person, I believe. It depends on the availability of them. With WebEx makes everything possible everywhere. I mean, you could be in a coffee shop learning math if you wanted to. But when I was in graduate school, we took our math to the bar. So just depending on how busy you are. All right, so that is a perfect time for this because we're done with half the course. So if you find yourself struggling right now, is a great time. You can still catch up. You can still get going. Remember, you can also replace all of your bad exams with better ones if you do better on the final. So a lot still is possible. You can replace your test grade. Yeah, it's listed in the syllabus how to do that. You can replace one outright, and then I average the other ones. You have a question? So this one outright. Mm-hmm. How do you choose which one is placed outright? Whatever is the best for you. Whatever yields the best for you, the highest score is the one I will take. And you can look at them at the end of the semester, and if you think I made a mistake, you can bring it to my attention. I can always fix it. Yes. Hmm? What was it going in tutoring? Would you recommend to get help with stuff? Yeah, I would. Because no, I wouldn't. Because the reason why is the stuff that you're learning now will include that stuff as part of the learning because it builds on itself. So by just doing the new material, you'll get better at the old material just because you're working harder material. For now, yes, I would say, but then the final, that's a different story. Then it's the whole, yeah. Yes, I do put one. It's optional, but it's during finals week, but I have it if you want it. Yeah. It's from whatever we had last time. So the way you can tell is, am I still in Blackboard? Let me see. I don't know if I'm in here or not. That's that. Oh, actually, I never was in Blackboard, was I? Here's how you can tell. I still got to fix up the syllabus in regards to the dates, but what is going to be covered is not an issue. We missed a day because of computer issues. And this course doesn't need to miss any day. It's so tight with time. This, because of that day, we're not having the test on the 28th. But here's what you will have always between the yellow lines is the material you'll study. That's in the syllabus, last page. That was before test one was that stuff. So after test one, so 4-1 through, yeah, this stuff in blue. You don't have to tell me anything about spring break. I will not question you on that. That's right. And then you can figure out the same thing for test 3. It'll be the stuff between these yellow ones. You understand? These are all dates. That's what these are here. So unfortunately, if you show up on this day, it's not so bad, you know, because you think some people who don't go to class or anything will show up on this day thinking it's a test. Well, that's not so bad because I can just tell them the test is the next day and they'll be able to show up then anyways. Yes, sir. That's tough to say. I would say the first one in some respect because it's got the most amount of material. And it's got the most material that we assume that you know, which that's a lot. This stuff is hard, especially this thing. What we're going to do here is extraordinarily difficult for students. The other stuff, I don't think it's that bad, to be honest. Most students do okay with line drawing, but this section, 9.3 is not too bad either. So yeah, chapter 1, I mean, the material does get harder as you go along, but that's, you see, we have a lot smaller amounts on the tests coming up. Other questions, any homework questions or anything, problems that you'd like me to do? If you have them, let me know. I can pull them up. What I'm going to do is today's lesson, I'm going to pull up problems from the homework. And that thing's annoying. Graphing here is a lot easier on the computer than it is by hand. That I think causes some issues with students as well because they're not used to physically doing it by hand, and that's the level of precision is not natural to a lot of people. Where was I going from here? I went to there. Oh yeah, the assignments. Yeah, I have the homework up here. So here's what we're doing today. You said you had homework from this stuff? Yeah, the homework you asked me, what question? This, okay. Well, we'll have a review. If you can find it, bring it to the review, okay? All right. Are there questions, any known questions, ones that you can tell me like, oh, 15, 16, something like that? Yeah, go ahead. You feel free. Okay. While he looks that up, I'll go ahead and show you the type of things that we're going to do here.
I think this does want to be short.
It's not actually. There's a lot of different types of questions too. We don't have like one or two types. See this right here? Like these type of questions, I don't really care about those myself. They're on there just to give you some work with your algebra. By the way, while I'm back here, come back to this page for a minute. I don't know how well you can see this. But this format, if I highlight, or I can't, it won't let me highlight it, but between the blue things here, you remember what that's called? They call it the standard form. This one we'll learn about today is called the point slope form. But I'm not ready for that just yet. I think what I want is a picture, and I think that's maybe where I'm headed for is I want to give you a picture, and I would like to make an equation based on that picture. So we've got it right there. Beautiful. It's exactly what I'm looking for. And I'll grab that part of it too. Now it says write an equation, so they're not being specific on the style of equation that you should write. But the most useful form in this class of any of these equations that we have ones that look like this. Once again, what is the name of that form? Well, it's intercept form. Why is it called the slope-intercept form? That M is the slope. B represents the y-intercept. So if you can give me those two quantities, something I guess they might call it, the term that you might think of is called a parameter. I don't care if you write that, it's not important. But they control what the line is going to do as much as anything. Can you, looking at the picture, can you tell me either what M or B is just by looking at the picture? Let's start with the easiest one that you can get. It's the letter B. Can you tell me, looking at that graph, what the letter B is? It's just a single number. So it's not, no, it's not 6. What is that called? What intercept does that be? The y-intercept. That means it's crossing the y-axis. So where is that thing crossing the y-axis at? -4. So this here. So when I'm making my equation then, I'm almost done. All I got to do is figure out what goes before x. How do I figure out the slope? Definition of the slope was what was it? Up or down and right. Exactly. So it's a fraction. How much does this thing go up? Well, you can go from point to point. So I can draw, if you want, myself this triangle here. Put a little square there. You don't have to though. How long is the triangle I just made? How tall is it forward? So the rise is 4. And this part down here is the run. So if you remember, it's M equals rise divided by run. Well, this is perfectly fine. That's 4/6. Almost certainly if you were to write an answer, or if you were to put down an answer and compare your answer to the one that they list, they will almost certainly list that number like this. That's exactly right. Now, the cool thing about this is, watch this. If I start here and I go up 2, 1, 2, and then I go to the right 3, I land right on the line, don't I? So it works that way. So even when you simplify, it still works.
So it's simplifying in that necessary step, or
It depends. For this one, no, it wouldn't have been necessary, because nowhere in that thing does it say simplify. Had it said simplify, you would have it. So you do not, I tell you, whatever the instructions say, don't do any more, because anything more that you do could be inviting an error. All right. So this is the nature of what we're doing today. I'm going to give you something, different things, sometimes a picture, sometimes not. And I want you to be able to come up with that style of an equation. So we have our equation for this. So doing it from a graph shouldn't be too hard. That got half. And then you can literally count your way to get the M, right? Now, as what happens, and you know this being the first problem in the class means it's also the easiest one. So we're going to complicate things from here.
it's like it's figuring out y-axis.
The main concept is the same problem. The entire homework is one problem in my mind. But the students, not so much. All right, now, same type of a problem, but it's complicated. Do you see how it's complicated?
It's fun.
It is farther apart, but that doesn't matter at all. What's the first thing we try to get when we're doing these things? Not the slope. The slope, I got second. I mean, I don't care which one you do first, actually. Let me make this as big as I can to fit on the screen. What was the first thing I tried to attack in the last problem? We know the shape. What is the answer going to look like? Hold this. So we need to figure out the letters M and B, and we have our answer. I did B first. Can you tell me what B is? Where is it crossing the y-axis? That B is where it crosses the y-axis. You want to think about it. I want you to think about this for a second. So you wake up, you're a little bit, flip over in the nurse place. Feel good about that? So the point I'm making here is we can't rely on that. So what do? This is a different type of problem. I don't have a B available. I just don't based on the picture. What I can do, I can still get out of the can't I? Look. I can still tell me how much it goes up or down and how much it goes to the right. How tall is that triangle that I just drew? Count your way, do a subtraction. Personally, I would be leery of counting to myself because I'll lose my place or something like that. So here, I look at this. Do you see the y value up here? What's this number? If I looked at the y value, that's a 5, isn't it? Yeah. And this one down here is a -5, right? Isn't 5 minus -5 equal to 10? So instead of counting, I feel a little more comfortable that way. That's my own personal thing. Now, how wide is that triangle? 6. Or you could have done 2 minus -4, giving you 6. So what is my M? Rise over run. What's the rise? Not quite, it's not 10. It's not, 10 is related to the rise, but it's not quite the same as the previous line. This one, do you notice that as you go from the left to the right, doesn't the line go in a downward fashion? Previous problem, the line goes in an upward fashion. When the line goes in a downward fashion, what they call decreasing, the slope is negative. So they'll call the slope -10 over 6. How do you know it's negative? What you got to do to keep your orientation here, for some people, keeping track of left and right is a hard thing to do. In these things, you not only have left and right, you have up and down. So you complicated things that way. When you start at the left one, always start at the left one. Tell me first to get from that point to the other point. Do you go up or do you go down? That's why it's negative. If you had, so you always go either up or down. Right. You always go right. Up or down will take care of the negative. This can be simplified to -5/3. So here's what I have so far. I'm almost done if I can figure out the letter B. And that's where it crosses there. I was trying to figure out the letter B. Well, one thing you should know is that each of these points, if I plug in this point here, what is that point? What's the coordinates of that point right where I'm pointing at? 2 and 5. It would work with the other point too. But what I'm saying is this: when x is equal to 2, what does y have to equal? When x is equal to 2, what does y have to equal? But the point is on that line. X value is 2. What's the y value? So what I'm saying here is that when x is 2, y has to be -5. So I can plug those in. When x is equal to 2, y has to be -5. You see that? 2 for x, -5 for y. What's so cool about this? Now I can figure out what b is. Because now that's just an equation like the likes of which we've had the whole semester. It may be a little painful with the fraction, but let me do this small bit of simplifying. If I wanted to solve that equation, what would I do next?
Multiply.
By
-5.
I would. Are you trying to get rid of the fraction?
Yeah.
Why not multiply by 3? If you I mean, the painful part of this is that 3, right? So if you can get rid of that 3, the whole problem's not so bad. And whenever you multiply 3, you can always do 3 over 1 like that. But look what happens.
Multiply everything.
That's right. The whole point of that is what happens next. I'm almost done. What are we gonna do next? Add 10. Add 10 to both sides. You add this 10. This 10. We have -5 equals 3b. We're almost home. Divide by 3. So we get -5/3 equals b. So I have the things I want. I have a b. Where do you go in? Feel like it's supposed to go. Lisa, settle. Oh yeah, I can do this. Here, this is. I have the two items I want, so therefore, what is the equation of the line? Y equals -5/3 x minus 5/3. Interesting. Knowing that -5/3 equals -1.66, and those sixes go on, so -1 2/3. The place where it crosses the y-axis, does that seem like that could be -1 2/3? I'm saying is, could it be? I know it's not 2, right?
Yeah.
It's somewhere in between. And if you look, to me, I'm satisfied. That looks like it's about 2/3 of the way past 1, doesn't it? It seems reasonable that -1 2/3 would be that thing where it crosses. So I verified, to me, that's a way of verifying that I did the problem correctly. That answer looks like it can certainly be true. So you can see the nature of these problems, there's also multiple steps, which adds another wrinkle. Now I can probably find one just like it. I think we should try one like it, where if the y-intercept is given, it's an easy problem. But if it's not given, like this, then it's a very difficult problem. Let's check myself. Oh, I gotta do it this way, huh? All right, I think I can try another. You guys ready to try one? All right. The excitement in your eyes, it just inspires me. All right, you can see bad looking y-intercept, you can't trust it. So what do you do? All right, so let's start. I'm gonna walk you through it because I know I want you to do it mostly, but I'm gonna walk you through it. Because if you look at the next test, and if you go to the old tests and look them up, these problems are on it. Yes, sir. Yes, I just got a bunch. We will have to do graphs today, but the woman in the math office bought me these. All right, so this is almost identical to the last problem. I cannot, and it's even decreasing. So the slope is going to be negative. So what do you do? The style of the problem, and by the way, when it says find an equation, it doesn't require any certain form. But the easiest one for most students is this one. So we want this. Now, I don't know the b. Since I don't know the b, what did I attack first? M. So start there. See if you can find the m. Sure m. See if you can get it. Oh yeah, the m is always rise over run. I want to give you enough warning because these problems tear up students when it comes to the test. They're just terrified of it. I don't think it's 9, is it? I got -8 over 10, yeah. Yeah. Oh, you don't have any paper. Here's a low sheet one, so you can have that. All right, were you guys able to figure out that the slope was -8 over 10?
See, where I messed up at is I counted, started from the bottom. So I got to the second.
I think the best way to do it, well, what I would do is negative, that would give you 8 for this distance. I mean, as long as you get 8, I don't care.
See, I'm doing it backwards. So
What?
Yeah.
And then over here, as long as you can give me these distances, you'll be all right. But then we decide whether it's negative or positive, depending on if the line's going up or down. How far is it from here to here? I think once again, it's easiest to pick the x's here. So what's 4 minus -6 equal to? And as you said, that's 10. So 8 over 10, since it's going down here, we know the slope is -8. And you can simplify that, of course, to -4 over 5. Now that I have that, do you remember what I did? Hit the B. Well, let me do this. Let me back. I should write. I think it's a good idea to write what you've accomplished to this point. Don't know me yet. I'm still at that point. How do I get that B? What did I do? I looked at the points I was given. Choose either one of these. This point over here, 6, 4. This point down here is 4, negative. Either one of these will work because it says this 4, -4 point says that when x is equal to 4, y has to be -4. So when x is 4, y has to be -4. See? Or -4. Yeah, the points are going to be, because we can count on these. They have a dot that tells you the exact location of them. So we have, this will be -4 equals -16 over 5 plus b. Now to solve that kind of an equation, what would you do next? Multiply everything by 5. So if you do everything, so you do -4 times 5, -16 over 5 times 5 plus 5b. If you look at this y-intercept, the b is a little bit less, a little bit bigger than -1. You see this? It's not -1, it's just a little bit bigger. My guess is it's gonna be like -4/5, I have a feeling. Oh yeah, okay, this takes. This will take care of those. So I'll have -20 equals -16 plus 5b. Add the 16. Like -40 or -4 equals 5b. I think I'm going to be right here. Divide by 5. So I've got my b. My m is up there somewhere. Yeah, this problem is extremely like the last one. Both these numbers do the same thing. We will have a review day to do more of these types of problems. Like, there's only so many I can do in a class, but I'm trying to give you a feel for these. And I want to do one that is probably the most. These, at least you had a picture to go from. And if you look, that -4/5, if you compare it with the graph, it looks like that could have been -4/5 where it crossed. Let me go to here, back to these things. And the one that I want deals with parallel and perpendicular. We can talk about that and review. That's not a big deal. Right here. This is what I want. There's two questions in this problem. You can see that right here. This up a little bit. These are the ones, I hate grading these every single time. They're nasty problems to grade. But consider the line, and they want you to find a line parallel to perpendicular. Now, perpendicular here. This line right here. Can you tell me what that means? And over here, this guy's parallel. Can you tell me what that means? Let me label these so I don't. So what? Look at part A. What's the slope of the perpendicular? It's hard for me to name myself. I'm so excited. What's the slope of the line they give me? What is the slope of the line on this view? Therefore, told you last time, what is the slope of the line that is perpendicular to it? And the slope here, I'll make it. What's the slope of a line parallel to it? Let's start with the easy one. Same, right. That's easy. Perpendicular is the negative reciprocal. The perpendicular is the negative reciprocal. Negative reciprocal. This is equal to 2/1, correct? Negative 1/2. This is what you have to know. Parallel one's easy, it's the same. The other one is the negative reciprocal. Once you have that, the game is over. It really is. Perpendicular is the negative reciprocal. Well, no, it's the negative reciprocal of the given slope. So 2 or 2 over 1. Flip it upside down, what do you get? Negative reciprocal. So once you have the slopes though, it's not that bad because for part A, let's go here. You know that the line already is going to equal negative 1/2 x plus b. I'll pause there. Do you understand why you know that that's the answer for part A? And while I'm at it, I can work part B at the same time. Here, y is going to equal 2x plus its own b. I don't know if I should call them different b's because they are different. They probably will not be the same b. Now, tell me how you get the b on the first one. No. There's a piece of there's numbers sitting out there that have not been used yet. That is, I had no idea that you're. You know, let me show you something before. I'm going to erase this, but I used to do something like this. We talked about linear equations, and I go, what is the base word to that? And the student didn't say line. You know what the student said? And I was not ready for that. Never in a million years was not ready for that. So it's the same thing. What did no, the thing that we have not used is the set is the point. In all the previous 2 problems, didn't I plug in a point? Plug the point in to figure out the b in both cases. Tell me, when x is equal to 7, how much does y have to be? 3. When x is 7, y is negative 4. So that means that this equation has to satisfy this. The other one will seem like fun compared to it because it won't have the fraction. So I made a mistake. That's exactly right. That's great. I just noticed it. That's all you need is the professor that's here. You see how I plugged it in now? The 7 went in the x slot and the negative 4 went into the y spot. Now I can solve each of these individually to get my b. To solve each of them, you can do exactly the same thing. I'm going to do this one first because it's easier. So that one's done. The parallel one was easier in this case. The other side then, to get b, what would you do? To multiply everything by, so 2 will wipe out the fraction. Yeah. So you could do this. If you get good at this, multiplying by 2, you can actually probably get yourself to level. See what I did? Just did it in my head. It doesn't mean you can't. I mean, I've obviously been doing it for a long time. What's 2 times negative 4?
So
The job of the 2 is to wipe out the 2 underneath the 7, isn't it? It's not. Oh, but it is, didn't it? I didn't multiply b by 2.
Wait, what did you do again with the fraction of 7/2? How did you erase the 2 again?
I remember I multiplied everything by 2.
So did you make it just a whole number 2, or was the 2/1?
So yeah, I would do 2 here, but then if you want to do it to work with here, you could do it as 2/1. You can do it there. So you multiply all 3 of them by 2. And then to finish that off, what do I do next?
7 plus 2b.
That's 7. -1 equals 2b. Then I'll divide by 2. And we get -1/2 is equal to b. So in this case, the slope was -1/2. Y-intercept, well, intercept was 1/2. So what you do want to memorize though, parallel, same slope, perpendicular, negative reciprocal.
Where did the 2 come from? That's -1 equals 2b.
This right here. Oh, it's here.
Right here, how did you get the 2 underneath?
I just divide by 2 because I'm solving an equation. Once you divide by 2 to get b by itself.
Oh, okay.
That's the whole thing. As you can see, the length of the problems are more complicated. They're definitely longer and they're more depthful types of problems as well. They're not just here, add these or multiply these things. You have to be able to read, understand, and put all that information together. That's a lot to ask for. All right, let's go ahead and take a 10-minute break there. Let's come back about 1 after, maybe 2 after. Does anybody still use wooden style pencils? I have one up here if you want. What? You still have pencil sharpeners in one. All right, I've only touched on a few types of problems. There's a lot more in there. Problem 11.3. Here's that graph paper. Because I do have straight edges. That one, you gonna use that? It's cool to put them in. So while we've done a lot of problems in 4.5, I did not do all of them. This is everybody has graph paper? I didn't check. Make sure, okay, make sure you have bona fide graph paper. It looks like I'm gonna change my background then. Let's see the view. Let's change this to these things. All right, well, I don't want to do that one just yet. Actually, that's a good one to do. Let's do that. You know what? Let me do this. Grab this part of it. What is the coordinate plane? Well, that's the thing that we graph on. Where are you at? There we are. That's what the whole point of doing this is going to tell you. All right, y is less than -6. Now, if I asked you to graph the line y equals -6, would you be able to do it? If I asked you to graph the line y equals -6, would you be able to graph that line? What kind of a line are those that's just y equals a number? Horizontal lines, that's right. So what I can do then, I go down 6 units. And I go 1, 2, 3, 4, 5, 6. And I'll put a marker. That's where -6 is. Okay. Now, draw the line. Horizontal line, go ahead and draw it. That is the graph of y equals -6 that I have on there. Are we okay with that? Y equals, no, what I graph, this line that I graphed here is y equals -6. Do you agree with that? Yeah, I'm gonna make it red just so we can see it. Well, what does this? This means y is less than. So what we want is which direction, if you're thinking of y is vertical. What represents greater than and what represents less than in the y world? Up are bigger numbers, down are lower numbers. So just like left and right, except it's up and down. But about y less than -6, I'm talking about down here. So what you do to indicate that is you shade. So let me draw really thick shading for this. I'll choose my, I don't know, where's, I don't want that one. Oh, whatever. Don't choose the gray. I want that big thing because I'm going to paint here. Talking about all this stuff down in here. Everything under there, yeah, it goes on forever. It goes down to negative infinity. It's only underneath of that line. You can just shade it however you want to shade it. Screw it, whatever, I don't care. Most students opt to shade it in one way or another. Just make sure that you don't limit yourself. This does go down to negative infinity. Do you understand? Yeah. Now, there's one more piece to this thing. There's actually two pieces to this. The other piece is to indicate that the line itself does not count. We make it dashed. So what I do for myself to do that, I go to my pen properties. That is not what I do, actually. I don't know why I do it. It has, I can treat it as a drawing. Not that any of that matters to you guys, but then it will allow me to erase things. And so I can really indicate this. Got to dash a line because it says they don't want the numbers that are actually on the line itself. Just the stuff below it. If this problem had been given, but instead of a less than, you had a less than or equals, that line would be solved. Because then all of a sudden, -6 itself would be an allowable answer. You understand that? So dash line when it's a strict inequality, solid line when it's the less than or equal. I don't compound inequality. That's not the right word, but I hope you understand what I'm talking about. Yeah.
Same thing, so there were.
And you use left and right parentheses, correct? So if that were x less than -6, we would have a vertical line for -6 and you would shade to the left. Yeah. This is, yeah, go ahead. Then you would shade the other side. Yeah, you shade on top of them. So the way it works is this. If I pick any single point down here, pick anything you want. So let's say I'm doing point picking. And I pick one down here. Just at random. Would you agree that no matter what that point is, you know for a fact that the y value is less than -6, isn't it? No matter what point I pick down there, the y value will be a number smaller than -6. No matter where that point is. Of course, that's the easiest of these style of problems, but they're not a whole lot different. Now watch the way you graph in here. What you do is you go and you lay down your line first. So you usually give it a point, like I want it to go through -6, right? You just secure it with a second point. You guys with me? This guy here will allow me to dash it. See that? Then to shade, I pick this and it lets me choose the region down here. That's it. Much easier here than by hand. Yep, if it's solid, we assume that you're allowing points to be on the line itself. Well, if you don't draw the line, people won't know where exactly where the border is. So that line is there, that's a border keeper, if you will. All right, let's go to the next one. Now, the next style of problem is a little more complicated, but not much more. So I'll pull this up. I'll use my graph paper though instead of theirs. Now let's review. What were the things that I did? When I graphed it, I graphed the line itself without dashing it or anything. I didn't care about that when I first graphed it. I just graphed the line itself. So we have this, we have y equals -5, y is greater than -5x minus 4. Let me fix my font size here. Pick this. So hopefully this is a really fast thing for you to do now. This is in mx plus b format. So if you were to graph this line, this -5x minus 4, what part would you pick first? No, I wouldn't. You'd pick -4 because it is the intercept. So let me put a point here. I don't want to use these ones, are too thick. Something tells me I need a 2mm pen, but I don't have one. So what I do then is I'm going to lay that down. So I start at the origin and I simply go 4 units down. 1, 2, 3, 4, and there's my y-intercept. Right. Can you tell me how I get more points than that one? Don't everybody yell it at once, because I can't hear all really at one time. How do I get another point? This is basic graphing of a line. This -5, what is that -5 right there? No, it is not. That's not the x-intercept. What is the number that occurs in front of x? The slope. -5 is the slope. So I've got my 4 down. Now, if I want to do, now I move -5 over 1. Do you understand? The number -5, I need to, because I don't know the run then, do I? If I just say -5.
Right.
So I start at this point, and the -5 says I go down 5. 1, 2,
Yes.
3, 4, 5, and then to the right 1 unit. I can reverse myself by going up 5 and going to the left 1 unit, and I'll do it one more time. I think for me that's long enough. So let me get my line then drawn through these points. Actually, the way I'm going to tell you is a little bit different. I don't know if it is, because I don't remember the order I went last time, but let me get my line in here. My point veers off, doesn't it? I gotta fix it. My point is off. I gotta fix this thing here. Grab it this way. That point was supposed to go through that point too. Why in the world? See, it's not working right. What is going on with my graph here? There's that one. Wait, 1, 2, 3, 4. Oh, you see what I did? I went 6. I went 6. I gotta get rid of that thing. I went 6. Did you see that? Okay, very few. Try this again. That's why it was not quite on. I got to go 1, 2, 3, 4, 5, and then so I want to go into that spot. My God. Go on, go on. Now it's going through all the points, a little better. All right, now, do you remember if I use a dashed line or a solid line on this? Dashed because of the inequality. That's right. So let me change mine to a picture that I can do that to. Treat it as a drawing. And then it will allow me to erase little pieces out of it. Hey, are you serious? Cut them out. There we go. All right, now the last bit is shading. Which side of the line do you think should be shaded? It's actually to the right. I'll give you in a minute. Let me get this, my dashes. I can get rid of that one because that point. The sign is greater than. That means that y, which way for y is greater than? Up or down? Up. So you would actually not to the right of it, above it. No. The whole up here, anything above the line, all of this area here is all included. Let me paint it. Well, let's pick a really ridiculous color over here. I'm talking about everything over here. I honestly do not have a good way of painting these things. Basically, what these lines do is they split the graph in half. You're right, they split it in two. There's two pieces. There's the left side or the above side. I mean, the lower side and the above side. Well, remember this. Let me grab a point and I'm going to click on this and I'm going to make a point over here. One way you can check yourself to see if you did the right side. Do you know how you can? You see I put a little dot here? Check this out. I'm going to check myself to see if I am actually right. So what I did, check myself, is I picked a point at random in the shaded area. 6. 7. You probably can pick an easier point. Like for instance, I could pick 0, 0 would have been easier. But I'm going to pick that point just to show you. That means when y is 7, x is equal to 6. So when I place y with 7, x was equal to 6. Let me simplify this side. Stop there. That's true. Therefore, that point belongs in the right area. Understand? I plug those numbers in and I arrived at a true inequality. Isn't it true that 7 is bigger than negative 34? Number 7 is bigger than any negative number, isn't it? So I plugged that in. I got a true statement. That means this point is part of the solutions. So that's the problem with these is you have an infinite number of solutions to all of them. It's a whole half of the plane. I don't care if you use color. I really don't care what you use. Just indicate you shade one way or another. Various things come within some people. Then when you go to do the homework, we'll compare their answer to mine. Remember, we put down the point -4 first. So I grab this line and I put the -4 first. Now, do you remember how to get a second point on this graph? What do? Use the slope. Tell me what the slope is. Here I am. I'm sorry. Is it too small of a screen?
Yes.
All right, so I got my point here. I've got the -4. Now, how do I get another one? Remember this, there's the number. What should we use to graph it? That's right. So I'm going to go here. I'm going to go -5 means I go down 5 spots. 2, 3. Now remember, the word over is not exactly correct. So we've got that. The point, now the line is locked in. Now what do I want to do next with the line?
Dash it.
Dash it. So you click this guy and you put your finger on it. It's dashed. Then the last thing we want after that is what? Shading. I simply have to pick the correct side to shade. Am I shading on this side or am I shading on this side? Right side, so I just put a click and there we go. Okay. So yeah, if you want, let me I'll throw it over here. It doesn't matter. But yeah, you can see they're most definitely the same graph. Just mine is much less pretty looking. But let me give you one to do. That's right. Remember, it's in y equals mx plus b format. In fact, they're going to give you, they don't quite give you y equals mx plus b. They give you in all of these problems is greater than x plus b. But it's the same structure. It's mx plus b. So the b is in the same spot and the m is in the same spot. Well, oh yeah, let me write you on it. Less than or equal. So that, what does that mean to the line? That's correct. Because now the points that are actually on the line are included as answers. right? If you look at my graph, I put my y-intercept at 4. You guys do that? And then after you have the y-intercept, how did you move? Right, so that means which way? You went down 3 and then to the right 1. And that's how you generated your points. Exactly. So my graph, look at your graph, be careful. Does yours cross roughly at about 1 1/3? X-intercept look like it's roughly about 1 1/3? Okay, now, which side should I shade? See, now I want you to think, right? Since Y is talking about up or down, think of this in terms of up and down instead of left and right. Does this mean Y is below the line or above the line? Don't forget worry about the equal. Is it? No, this symbol is less than. You guys know that, right? Y is less than or equal. So which am I talking about, up or down? That's down here. Down here is below the line, isn't it? If I'm here, if I'm standing at this point here and I look up, I will see line, won't I, up there? So it is above me. When it's just the way that it's almost vertical, we want to be left and right. So I'm shading to what really is below the line in this stuff over here. And the solid line indicates that the points on the line itself are solutions. That's the weird thing about inequalities, is that they have an infinite number of solutions pretty much every single time. So anyways, let me go ahead and, I didn't know it would take that long, but whatever. Oh, that's right, I didn't pick it from here. Okay. Personally, I will not give you one like this on a test, so it's a little bit harder than what you would have to do on your next test. Oh, once again, I didn't want that part. I got. I'm happy with you being able to graph the line and telling me you shade above or below it, or to the left or to the right of it, whatever, as long as you can shade the correct thing. Why is this problem more difficult than the other problems? It's because that you notice that Y is not by itself, is it? So you can, if you want to, you can make up a chart of X and Y values if you'd like, and that's one way you could graph the line. Another way of graphing the line is to solve it for Y. What kind of a line is going to be when I'm done, by the way? Solid or dashed? Solid line. So we've got that going for us. We know that. I'm going to solve this inequality for Y. So if I try to get Y by itself, what's the very first thing that I would do? You're solving this inequality. Really, it works just like an equation for the most part. If I want to get Y by itself, what should I do first?
Switch it around.
Why would you do that? Why not have 2x both sides?
Raises 2x to that side.
Right. That's what I want, because on this side, when I divide by this number, I'm going to have an M and E. We're almost there. What's next? No, you're not solving for X. Y by itself. -5 is glued to Y. How do I get it off of it? 5 by -5. However, you guys remember, there was one sort of thing with inequalities. Divide by a negative number, it turns it around. Do you remember this? No, I'm not talking about positive. Look at the way they're shaped. Students have come into my class and they have mentioned things about alligators eating smaller numbers and things like that. It's eating bigger numbers. So you must have, at least when you're in elementary school or wherever, you must have noticed that it being pointed that direction means the opposite of it being pointed in this direction, correct? That's pointing that way, correct? That's like a tip of an arrow. Pointing that way. Now it's pointing this way. I want you to understand it. The reason why I did that is when I divided by -5, it has to turn this around. Yeah, equal will still happen. So let me give you an indication of why that is. Suppose I have, I'm going to make up another letter. We're going to use Z so it doesn't confuse this. And I'm using weird letters and everything like this. But you know what? What I'm going to do is I'm going to add 7 to both sides of this inequality. But don't ask why I'm doing it. I'm just showing you that I. And negative, well, again, it's so there's a couple things to digest here in this. All right, what I'm doing here, this has been a side. This is not related to the problem. Gave you an inequality. Z is less than or equal to -7. Then I can use basic algebra by adding and subtracting to get Z, -Z on the other side. Do you agree that the last line I'm circling here is identical to this line? Same thing. It just says, in both cases, it just says 7 is less than or equal to -Z both times, doesn't it? Now look at where I started. I started with Z is less than or equal to -7. Now, if I multiply both sides by -1, doesn't Z become -Z and 7 become +7? But look at the inequality. It's pointing in the other direction, isn't it? So when you multiply or divide by a negative number, the pointer turns the other direction. So when I divide by -5, multiplying and dividing work exactly the same when it comes to this. When I divided by -5, I made it a point to tell myself that I needed to turn it around. This is crucial because if you have this wrong, you're going to shake the wrong side, aren't you? With the whole point at the end is which side is it going to be on? If you don't turn that around, you will shake the wrong side. So anyways, let me go ahead and clean up this side. When I divided by -5, all it left was with y. Here, you're allowed to break this up into -2/5 x plus 4. I'll pause there while you digest what I just did. Yeah.
You get into the problem that you said, you started off by adding 2 to both sides.
2x.
2x to both sides. Where did you add the second 2x to? Like, I see you added it to the negative 2x, that's what canceled that out. But the other 2x, where did you add
And
it?
if I add it to both sides, like if I add 2x, I just didn't do this step here,
Yeah, I didn't physically see you, so I didn't see where you added it to actually.
but you will, these will cancel out.
So you put that one just in the space by itself, you added it to nothing.
Yeah, because I can't combine it with one.
Okay, got it.
Yeah, they're on, they're on like terms, so. And then you know, that when you have something like this, you're allowed to break it into two pieces, 2x over -5 and -20 over -5. When you have the -20 over -5, that's how it became positive 4. But with all of that said and done, did you notice that the problem that we have right now is the nature of it is identical to the previous problem, isn't it? Now it's in the stage that we can graph it. So they gave it to you in what would be something called a standard form, and it's going to be easiest to put it into slope-intercept form. However, I did say one thing. If you want to leave in the form that I have it in the beginning of the problem, if you don't want to solve it for y, you'll have to make yourself a chart, the x and y chart. Remember that? And you graph the intercepts. So you can. There's more than one way to graph it.
Let's go with this one here. So there was some work to do before I can actually graph the thing. But I'll see if I can sneak it in here. Now, when I'm going to go graph this thing now, can you tell me what is the first thing I should lay down? The 4. So let me go here and I'm going to choose myself. Here it tells me the sizes. So I like the 2.1. So, all right, I'm at, and dang it, red. All right. So tell me how to get, I'm at the origin. Now, where do I go? 1, 2, 3, 4. So I can put a dot there. Now I've got that. Now tell me how to make other points. Down 2, right 5, 2, 3. And then just repeat it. Keep doing as many as you need. 2, 3, 4. And then reverse yourself as needed. And then I guess for maximum accuracy, what I could do is choose, I could do like that super thin one, but nobody'd see that one. Let's do that one. I think I'm good. All right, now I've got that. Now, how should I shade? This is the guy here. Look at it, stare at it. That says above to you. What is that? Tell me, say that. So which side is it? Below, yes, below. Thank you. Go big gaudy yellow. And you don't have to shade, you don't dash it at this time, do you? So that one, we laid down our line, we had it at 4. I'll put it, now what do we go down 2 into the right 5? I think I'm in the right spot. So it'll lock it in. I don't have to dash it. And then I'll choose my region, which is down here. And we got it. Any questions? Do you guys want to try one just like it? All I got to do is this. Oh, this is a cakewalk one. This is an easy one. Go ahead and try it. It's easier than the last one, but it's the same style. Did you guys get this side? Yeah, because y is going to be less than negative 4x minus 2. Did you get y is less than negative 4x minus 2? If you got y is less than negative 4x minus 2, isn't that below?
So I'm talking about the first thing you want to do is solve it for y. So you say y is less than negative x minus 2 by subtracting 4x from both sides. And that's the part that keeps throwing me up. You gotta get y by itself.
Yeah, I know that part, but I'm saying subtracting from both sides, like, I don't see another number to subtract the 4x from on the other side.
Yeah, that's why I can't combine them.
So you just add it and
It's
it's
just over, yeah, it's over on that side. You can't combine them, that's the thing, they're not like terms. We don't care about it, all I care about is, this is before my what, isn't it? The slope is -4 and the y-intercept is -2. -2 for the y-intercept. If you go down 4 and to the right 1, you can generate the new points. Okay, go ahead.
It's like 2y,
How did you get 2y?
side of it, 2.
Stop. How did you get a 2y?
Oh, because, okay, so I subtracted 4x and just left 2y on.
So you subtracted 4x and you got something different from what I have written here.
So 2y side is 4, so I divide by 2, so -2 divided by 2. I left that as a fraction.
I have no idea where you're. You say you subtracted 4x to begin with, right? Correct. Wait, left is y. The only thing left there is a y. There it is. There's no 2y anywhere. That's 1y. You understand.
So you can figure it out where I get to the.
You can't combine them now. Now, this is the structure of what we've been graphing all the class. The slope is -4 because it comes right before the x, and the y-intercept is -2. Down 2. Then after I got that, what did I do next?
So,
No,
down 4.
down 4 and then 6. That's how I got my subsequent points. Now, one last question. How did I know to shade over here and not on the other side? Because it's less than. If y is less than, you're technically shading below the graph. I know that's weird to see, but I want you to think of something. You are here. If you look straight up, when you see the line, yes, you look at you. That means that's you're in the correct thing when you think of it a little bit that way. But since it's so vertical almost, we want to think left and right, it's tough for us. So, sorry. I know when it gets exciting, it just goes so fast. But we have a class 10 under us, so I got to get out of here. Leave me your 2 rulers, you guys, whoever borrowed them, so I can put them back. Export this. First. Stop the recorder.